In this episode, we are going to check what is properties. Properties associate values with a particular class, structure, or enumeration. We have two types of properties. One is stored property and another one is computed properties. Stored properties store constant and variable values as part of an instance, whereas computed properties calculate a value. The stored properties are provided by classes and structures. Computed properties are provided by classes, structures, and enumerations. So, what is the difference between properties and variables? Properties belongs to a object, whereas variables do not. A variable can be declared without having to be associated with a particular class or other object. A property must be associated with a particular object. Let us check on what is stored properties. A stored property is a constant or variable that is stored as part of an instance of a particular class or structure. Stored properties can be either variable stored properties or constant stored properties. You can provide a default value for the stored property as part of its definition. You can also set and modify the initial value for the stored property during initialization. Let's take an example. We have a structure range and having two properties. One is variable first value of type int and the constant property of name length of type int. Let's create an instance of this structure. The range is equal to length So in this example, the instance of fixed length range have a variable stored property called first value and a constant stored property called length. We can change the values by dot first value is equal to 3 2. Okay, this is all about the stored properties. We can also provide initial value, for example 30, and okay, this is how we can give values. Next is the computed properties. In addition to stored properties, classes, structures, and enumerations can define computed properties, which actually do not store a value. Instead, they provide a getter and an optional setter to retrieve and set other properties and values indirectly. Let's take an example. We have an struct point with values for x equal to 0.0, y equal to 0.0. Then we have another structure, size for width equal to 0.0 equal to 0.0. So in this both structures, we have stored properties. In here we have x and y. In this size structure we have stored properties width and height. I am going to create another structure rectangle. It's a variable origin, that is an instance of point, and another one size, that's instance of size. Okay, so next we have a property center of type point. For the center property I am going to calculate the value instead of assign a value, so it will be an computed property. So after the declaration, put the curly braces. So we need to provide two methods. One is getter and another one an optional setter. Okay, in this getter we are going to return the value of sender. So I am going to calculate the value of sender. Let sender x is equal to origin dot x plus size dot width divided by 2, and let sender y is equal to origin dot y plus size dot height divided by 2, and return that value, return that point, return point of right. X is sender x and y is sender y. Okay, next is the setter method. Setter method, we will get an variable here, new value. We can provide any name here. Default it will get new value. So origin dot x is equal to, so we get the new sender. We are going to change the origin. New sender dot x minus size dot width divided by 2. Same for y. Okay, this is all about the computed property. We have a getter and a setter, optional setter. See how we can use this. We are going to create an instance. Square is equal to rectangle of origin. We have a point. Of x 0.0, y 0.0, and size width 10.0 and height of 10. Let sender is equal to square dot sender and let's print it. Square dot origin dot x square dot origin dot y. Square standard dot x standard dot y. 10 10, and I'm going to change the center here. Center, sorry, center. So I'm going to provide a new center. Just center square dot center is equal to new point, for example 30 40 40. Okay, we got the square of the center have been changed to 40 40. Okay, this is all about the computed properties. We can also do some optimizations here. Instead of a new center, we can use some new value. Also for getter, the entire body of the getter is a single expression. The getter implicitly returns that expression. We have more lines. So we're going to for x I'm going to change with so it's a single expression. We don't have to explicitly point return. It will automatically return it. Got it. There is also we can declare the computed properties with a read-only. It's called a read-only computed properties. A computed property with a getter, but no setter is known as a read-only computed property. For example, structure cuboid width equal to 0.0, height is equal to 0.0, and depth is equal to 0.0, and we have a computed property volume of type double. So is a return with height into depth. So in this case there is no setter. So this is a read-only computed property. Observers. Property observers observe and respond to changes in a property's value. Property observers are called every time a property's value is set, even if the value is the same as the current value. You can add property observers to any stored properties you define, except for lazy stored properties. Also can add property observer to any inherited properties, stored or computed, by overriding the property within a subclass. You don't need to define property observers for non-overridden computed properties because you can use setter in computer property for observe and respond to changes. Let's check an example. We have a class step counter. We have a stored property total steps of type integer equal to 0. So I am going to add the property observer to this property. By adding, use the curly braces, and we will have two methods: will set and did set. Will set is called just before the value is stored, and did set is called immediately after the value is stored. So will set. The new value, we can use any name. Total steps and did set, or okay. So these are the two methods being called when a property get changed. We can check what are the values. Print so I'm going to change the value of total steps. So in first we'll execute the will set, and here the new value will be 100 and the old value is 0. On this did set method, the old total steps, the old value will be 0 and new value will be 100. This is all about the property observers. Next we have to check the property wrappers. Okay. You can check this by an example. We have a struct 12 or less. Okay, in this structure, we are going to set a number that will be less than 12. Okay. So every time the value is called, the number is called, the value will be less than 12. So property wrapper, we need to give an attribute here, and we need to add a property called wrap value. Type int. Okay, and inside that we need to add getter and setter. So return number and set. Here we do the logic. Number is equal to minimum of the new value and the total. So how we can use this? We can create an instance of this structure. Wrap value is equal to 2010 print wrapped value will be 10. I'm going to change the value to 100. See this, even I put the value to 100, I got the output as 12 because we have an wrapped value with a condition on setter. So we can check how the actual usage of this property wrapper. We have another structure. Small rectangle. Then I have two properties: width and height. Okay. And I am going to create an instance of this is equal to small rectangle and rectangle dot height is equal to 20 and print so here I'm going to make an rectangle with the size will be less than or equal to 12. For that, so the small rectangle, the width and height should be less than or equal to 12. For that, I put a wrapper here, 12 or less, and also for the width 12 or less. Okay, so let's check what the value. If I put 20, it will be 12. Rectangle will be okay. This is the use of the property wrappers. We can also achieve this without the use of the special attribute syntax. Okay. Structure little rectangle So we have two variables var width of type 12 or less and var height is equal to 12 or less. Okay. And we have a computed property same for height also. Can use the same example here. Little rectangle. Okay, so this is the same example but without using this special attribute syntax. With use of the special attribute syntax, it is very simple, only just 2 lines. Otherwise, we need to do like this. So it will better be used using this syntax. And we can also set the initial values for the wrapped properties. Check an example. We have a structure small number with two properties, maximum and number. Maximum type int int. So this is a property wrapper. So there should be a property wrap value of type int with a getter and setter. Okay. With getter we return the number. With setter we do the evaluation. The number is equal to minimum of new value and the maximum. See this, if I change the value of this property, it won't work. Property wrapper type small number does not contain non-static property called wrapped value. So every property wrapper should have a property named exactly as the wrapped value. Okay, let us have some constructor behind init without any param first. Maximum is equal to 12 and number is equal to init. Next, init with only one param, wrap value int. Here maximum is equal to 12 and number is equal to minimum of the wrapped value and maximum, and another constructor with two properties. Int and another property maximum int save dot maximum is equal to maximum and number is equal to minimum of wrapped value and maximum value. Okay, so in this property wrapper we have three initializers. So see how we can use that. Enhance structure 0 rectangle with wrap property small number var height and is equal to 1, small number. Here we have the initial values, wrap value 4 of var equal to 2. This should be maximum. And 4 of value 1, another with okay. Row rectangle print rectangle dot height dot width so height will be 1 and width will be 2 and another width will be the minimum value 3. So here I am going to change the value to 100. What will be happen? That will be, in this case, right, the maximum is 12, so it will print as 12. Just change to 50 and see what the value. It will be 50. Okay. And in this case, we put the maximum as 4 and we put the value 5. We got the value 4. I'm going to change the value to 3. We will get 3. Right. And I'm going to change here, the maximum is 10 and put the value 30. So we got the value 10 as a maximum. In here we have wrapped values 3 and maximum is 4, so we can control over what the value here. So I got the value 30 and maximum is what, for example 20. We will get the value 20, right. And I am going to change the value to maximum is 100 and the wrapped value is 80. So we got the value 80. So this is how setting the initial values for wrapped properties. Next, the projecting a value from a property wrapper. A property wrapper can expose additional functionality by defining a projected value. The name of the projected value is the same as the wrapped value, except it begins with a dollar sign. So we are going to check the projecting values. So we have a structure, small number, that is a property wrapper. So we have a number, and there should be a variable called wrapped value of type and have a getter that will return the number, and the setter here we are going to set some boolean. Okay, so if the new value is greater than 12, then do something, or else greater than 12 we put the number as 12 and the bool. We also need a boolean where projected value is equal to false. So projected value and wrapped value. So projected value equal to true. If it is changed, I put the projected value is true. Otherwise, less than true, the number value, and the projected value is equal to false. Okay, what is the difference from the previous example is, in this example I have put a projected value and changed the value of that projected values to true and false on this wrapped value. So how we can use that? This structure, property wrap, small number, some structure is equal to some structure for some structure some number is equal to 4 and parenthesis some structure dot we have a value with dollar sign. This is the projected value. Got it? Let us check. It will be false. The value, some number is less than 12. So come here and I put to 40. It will be true. So this is the use of a projected value. So a property wrapper can expose additional functionality by defining a projected value. The name of the projected value is the same as the wrapped value, except it begins with a dollar sign. Let's check what is the global and local variables. The capabilities of computing and observing properties are also available to global and local variables. Global variables are variables that are defined outside of any function, method, closure, or type context. Local variables are variables that are defined within a function, method, or closure context. Stored variables like stored properties provide storage for values of a certain type and allow that value to be set and retrieved. However, you can also define computed variables that define observers for stored variables in either a global or local scope. Computed variables calculate their values rather than storing it, and they are written the same way as the computed properties. There is another property, type properties. The instance properties we have seen are properties that belongs to an instance of a particular type. Every time you create an instance of that type, it has its own set of property values separate from any other instance. You can also define properties that belongs to the type itself, not to any on instance of the type. There will only ever be one copy of these properties, no matter how many instances of that type you create. These kinds of properties are called type properties. Type properties are useful for defining values that are universal to all the instances of a particular type, such as constant property that all instances can use, like static constants in C, or a variable property that stores a value that is global to all instances of that type, like static variables in C. Stored type properties can be variables or constants. Computer type properties are declared as variable properties. Structure. We are going to create a static property. The static keyword and variable stored type property string and another static variable static property computed type property term. So how we can access the static properties, so we don't have to initialize it. Some structure dot store type property, some structure dot completed computed. So this is all about the type properties. We can also declare this in a enumeration or in a class. Thank you. This is all about the properties in C programming language. Thank you.